our well plate here. It's a 6x4 well plate, so there's 24 wells, or little holes. And we're going to be putting our solutions into this well plate so that we have them all in one place. It's easy to work with then. Now here's the map. I just drew out the map from the lab book. And you can see where everything is supposed to go. Here's our lead 2+, copper 2+, iron 3+. And it's just the metal ion name, but they're all going to be nitrates. So this is lead 2 nitrate, copper 2 nitrate, iron 3 nitrate solutions that are going to go in here. So lead 2 is in the upper left-hand corner, and that's this well right here. And so we're going to put the lead there, then the copper, then the iron, all the way across. And you can see that we have all of these solutions will go into this well plate. And then once we have our stock, then we're going to use that and transfer them to the plastic sheet where we're going to have the reactions. So next thing we got to do is load this up. Okay, so we're going to fill this up. I'm not going to show all of these, but just get it started. So you can. This is our lead nitrate, and I'm going to put in about 10 drops or so, maybe a little bit more. Won't need that much. And that one is colorless, so it's hard to see. So copper here will be a little bit easier to tell what's going on. So that's our copper nitrate, and that's going to go here. And this is a nice lab with the different colors. It gets a lot of really interesting reactions. So that is our copper. And then we have iron. In this case, it's in a different kind of bottle. Put there. And then we have our cobalt. So the copper is blue, the iron is kind of a yellow or orange, and then the cobalt has a pink color to it. That. And then after that, pretty much everything else is colorless. Here's our zinc. So at this point, I'm going to just fill up the rest of them, and then we'll come back and take a look. Okay, so we have the entire well plate filled. A couple of things is that, you note up on the top, these ones are all the metal ions. These are all the cations. At the bottom, we have ammonium sulfate. It's a sulfate we're after. Sodium sulfide, ammonium thiocyanate, then the sodium hydroxide. It's the anions here that we're after, the sulfate, the sulfide, the thiocyanate, the hydroxide, and the ammonia produces hydroxide as well. And we're going to match those anions with the cations for all these different reactions. And then we're going to have two unknowns, and we're going to test them out and see how they compare to our knowns and figure out what unknown metal ion we're dealing with. One other thing here is that this is actually ammonium sulfide, not sodium sulfide, but it's the sulfide we're after. It has this nice color, but it reeks in, it's like rotten eggs, but like 10 times worse. So. All right, here is the sheet that we're going to be doing our reactions on. It's actually out of the lab book, but it's in a plastic cover, so that the reactants, the aqueous solutions here, will bead up on the surface and we can do all of our reactions. So what we're going to do is, here we have the lead, and this is our column. So every circle is going to get a drop of lead. For copper, every circle will get a drop of copper solution, and we're going to do that for all the metal ions. And then over here we have ammonium sulfate, so we're going to put a drop of ammonium sulfate to react with the lead, the copper, the iron, the cobalt, the zinc, all the way across. So you can see all of those, all of these columns and rows will give us, what is this, 7, So we're going to have 56 different reactions going on, mixing every cation with every anion. Now I'm going to be using this transfer pipette to put the solutions onto the sheet. Just go from onto the weld plate over here. And in between I'm going to just wash it out with water and put it into a waste container. That way I only have to use one transfer pipette. I could certainly use whatever 10 or 12 of them if I wanted to, but that would be kind of a waste. So okay, so we'll start with the lead. I'll get it on screen here. So this is the lead +2. So lead 2, oops, okay. Don't have any bubbles in there. Transfer down, okay. So we're gonna go here and put a drop here. And on each of these circles, now notice the circle is half black, half white, and that's so that it can show any kind of color changes easily. Some color changes are easier to see against white and some against black, so everything's covered there. All right, so I've got all of the leads, so I'm gonna drop the water here. I guess I can do it here. You can see, just draw this up and squirt it out, draw it up, just so you can see what I'm doing here. So, okay. All right, so and then I go to copper. So take the copper out, and I'll go, oops, there. Drop there, 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 and okay. So the copper is done. Okay, so you can see there's going to be a lot to do here. So I'm going to take each of these ions, and so there's going to be 7 drops of iron 3, 7 drops of cobalt 2, all the way across. So let me do those off screen. Okay, here are the completed columns of metal ion solutions. And so that's all done. So the next thing will be to take drops of ammonium sulfate and go right across the row. Okay, so we're gonna now use the ammonium sulfate, and I'm gonna put a drop of that onto each of the metal ions. I'll make sure I get the right thing here. Yeah. So go to that well and get the ammonium sulfate, and I'm going to do this. Oops. Okay. 1 drop here. Drop here. Drop here. Big trick is not to overdo it and send this stuff splashing all over. Okay. You can see that this was, I'm going to give a close-up of this at the end, but you can see that there was a cloudiness to a couple of them, and that was due to the reaction. It's a precipitation reaction. So if you see a cloudiness, that's a precipitation reaction. The next is the sulfide. It says sodium sulfide, but this is ammonium sulfide, but it doesn't matter. The cation isn't important here. It's the sulfide. So let's put this on here. Drop here, here. We can see a very definite color change. And I'll do, let's see, whoa. The waste container is getting really dark from that, just from that sulfide. Okay, and then we have the ammonium thiocyanate. Make sure I got the right one. Okay. And put a drop here, 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 here. Okay. And I'm going to stop here. I'm going to just move the camera and so I can see the rest of them there. But that's the first 3 sets of reactions. So next we have the sodium hydroxide limited, which is the 0.5 molar. That's sodium hydroxide. And make sure I get the right well. It's the big problem here. Okay. So we do here, here. Go. And okay, and then the next one is the sodium hydroxide excess. So that's the 4 molar. And that is here. Okay. So excess here. Oh, ran out. I think I did that one, but I'll do it again. Okay, that's the excess. And then we got to do the ammonia. It says ammonia plus water, meaning aqueous ammonia. And the limited, so that's going to be the 0.5 NH3, which is here. Okay. And then the ammonia plus water excess, which is the 4 molar. And that is right here. Okay. And let me see. Oh, here we go. These we can mix them up a bit just to see. Get something else. This one has 2 colors in there. That's neat. Okay, so and then this line here, the petroleum ether, that's not part of this experiment, so we're just going to focus on there. So here's all of our solutions reacting with all the other solutions, all 56 reactions. And I'll do a close-up here next. All right, I'm going to just look at 3 rows at a time here up close. You can see the lead with the ammonium sulfate, the copper with the ammonium sulfate, all the way along. And then so we have all the metal ions reacting with sulfate, sulfide, and thiocyanate. And you just write down what you observe. And then if you see any reaction, you write down, you match up the cation with the anion and show what compound must have formed. So if you see a cloudiness, that's a precipitate. If you see a color change, there is a reaction there too. Just keep in mind that there's the white part and the black part of that circle. So if you can see both of them, that means the solution is clear. And then I'll show you the report sheet. So to fill out the report sheet, you in the upper box, you write any observation you saw for each of these reactions. For the lead and the sulfate, I said that it's cloudy white. Probably should have put precipitate, but that's what I wrote. You can write it, your observations in any way you like. But since there was a change, I wrote down that the cation must have reacted with the anion, and I wrote the formula, lead to sulfate. For lead and the sulfide, there was a gray precipitate. That's what PPT means, precipitate. And so the compound must be the lead to sulfide. Now, not everything is going to react. So down the line here, I left the rest of these blank. You have to fill them in. But the potassium, nothing happened. So I would leave that blank. So you'll have a lot of blanks, but the ones where something happened, you have to write your observation and then also the chemical formula. All right, so we're going to do the unknowns next. So the unknowns, if there was room, we'd just put them in two more columns, but we ran out of room on the sheet, so they're at the bottom. So now, instead of going from the top to bottom, I'm going to go left to right, putting in this unknown. And it's one of the metal ions that we did. We just don't know which one yet. It doesn't have a color, so we know that it can't be copper, iron, or cobalt. And here's a second unknown. So these are what we're going to react. And so we're going to take, got to get another, all right, so got to get another transfer pipette. And I'm going to put the ammonium sulfate onto each. Now you can see the ammonium sulfate, instead of going left to right, is going to be top to bottom here. So the unknown is reacting with the ammonium sulfate. And then this unknown 2 reacting with the ammonium sulfate. Each of the unknowns reacting with the sodium sulfide, or actually ammonium sulfide. And I'm just using the stock solutions here because I ran out in the well plates, so for some of them. And then we have the ammonium thiocyanate. Okay. And then we want the sodium hydroxide limited, so that's going to be the 0.5. Oops, there. And then we'll do the sodium hydroxide excess. Oops. And then here. Okay. And then the sodium the ammonia, where's it? Okay. The aqueous ammonia limited. Put it on both of the unknowns, and then get the excess. Oh, that's strong. Oh, it's almost as bad as the sulfide. Wow, okay. I'm taking it right out of the stock bottle because I ran out my well plate. So here are all the reactions of our unknown. It's one of the 8 knowns that we've done. We just don't know which one yet, and I'll show you what you need to do to determine which one are which. Okay, here's a close-up of the unknowns. They're reacting. Okay, so the last thing you have to do is fill out the unknown report sheet. You have to figure out what unknowns are which. So for unknown 1, when I added the ammonium sulfate to it, it turned a cloudy white. So I look at the knowns, look up at the upper part of the reaction sheet, and you see that lead and barium also formed a cloudy white precipitate, so I checked each of those. Nothing else formed that cloudy white precipitate, so I left them alone. So what you want to do is go down each of the ions, the anions, and see how they affected the unknown. Write down the observation, and the observation might be that nothing happened. Then you just check off each of the ions where nothing happened. What you're going to find is that one of the columns has the most check marks. And hopefully it has all of them, but if not, it's the one that has the most check marks. That's the winner. That is the ion that was the unknown. And then do that for unknown 2 as well.